So I want to continue my discussion about TypeScript. I'd like to get through most of these slides today and then get on to really what we should be talking about, which is distributed systems, but we'll see how far we get. So the last day, anyway, from a syntax point of view, we know that the at the core of TypeScript is this thing called type annotations. This is how we declare the type of a variable. Using this postfix syntax, as it's called. So you can just see a simple example of it there. And once you attribute a type to a variable, then from there on, that variable can only be assigned values of that type, unlike JavaScript. So that's straightforward enough. Then we said that TypeScript supports classes. Now, I didn't delve into it very much because we know a lot about classes already. So there's enough on the right-hand side there to tell you show you what the syntax is like. TypeScript also supports interfaces from a classes point of view. And again, we have an example there on the right of the syntax, and I didn't feel it necessary to elaborate on that. The first new feature that we came across is interface data types, which essentially is a way of declaring a type for a data structure or an object structure. And we have examples of it there, a person type. And then when you declare variables, you can attribute that interface data type to a variable. And so again, just as with primitives, you're controlling the values that can be assigned to variables of that interface data type. And the point also, whether I illustrated it or not, is that certainly within VS Code, the compiler helps you as you're typing your code, as you're typing on the keyboard, when you declare a variable and say it's of a particular interface data type, then the compiler will only allow you to add or to define properties that are consistent with the type. So there's that kind of assistance that you get from the IDE. Then I mentioned type aliases. Type aliases, just as interface data types allow you to declare custom types for your own data structures. Type aliases allow you to do the exact same, but they also allow you to do more elaborate things with typing, as we'll see in today's lecture. Type inferencing is a really important aspect of the language, which is this idea that the compiler will infer the type of a variable based on the values that you assign to it, or value that you assign to it. You don't have to always use type annotations, whether you're declaring variables or declaring functions. And that was a big plus point for the language, and also helped in its adoption by the community. Because as I said the last day, it simply meant that you as a developer could be more productive by virtue of the fact that you didn't have to physically type as much syntax as you would have to if type inferencing wasn't available to us. Roughly then we finished off around here. We talked about functions. When you're declaring functions in TypeScript, you also have to use type annotations on the parameters of the function and on the return type of the function, although the return type is sometimes optional because the compiler can infer the return type based on the return statement within that function. I think that's where we left off the last day. We know that JavaScript has this notion of higher order functions. And so does TypeScript. A higher order function, to remind you, is a function that takes a function as a parameter. We refer to the function parameter generically as a callback. And so the question is, how do we indicate the type of the callback in this annotation syntax. And so we have an example here of a function. It's not a very useful function, but it's a function anyway, called print to console. And it looks like this function takes two parameters. Takes a parameter called text, which is of type string, and we have a second parameter, which I decided to use the name callback, although it's not a very useful name. But the idea here is that this second parameter is meant to be a function, and here's how we, where am I? Sorry. Here's how we indicate the type of the function. We have to indicate, essentially, it's the signature of the function. And for this particular case, whenever we use this print to console and we pass a callback function to it, that callback function has to honor this signature. It has to be a function that takes a single parameter of type string, and it has to return a string. And so that's essentially the syntax. Just by the way, if a function in general returns nothing, and that can be the case, sometimes functions just do some processing, but don't necessarily return a result. This has got nothing to do with higher order functions now, the point I'm just about to make. But if a function returns nothing, then returning void is how we indicate that in TypeScript code. And so that applies here actually, because this function doesn't have a return statement. It just does a console log. What does it do? It does a console log, and it doesn't have a return statement. So it returns nothing. That's why we're using void there. But back to the core point of our callback, and this is how we state the type of the callback. This is the syntax that we use. So it's a bit like the arrow syntax, as you remember from last year. Here's another example down here. This is array mutator. The idea I had in my head when I was coming up with this example is this array mutator function. You give it an array, and in this case, it's going to be an array of numbers, and you give it a function, and the function is meant to iterate over this array and produce the result. And the result will be an array as well, where each entry in the result array will be equal to the value of the corresponding input array after it has been, if you like, processed by the mutator function. But the mutator function in this case, okay, it takes a single parameter as well of type number, and it returns a number. And this overall function, this array mutator function, returns an array of numbers. And you can see here what the body of the function is doing. It's using the array map type to map over my input array, if you like. And it invokes the mutator callback for each entry in this source array. And what the mutator does depends on what function you pass to it when you invoke the array mutator. I think I can switch over to the VS Code just to look at that example. Let's see, where did I put it? Here it is here, array mutator. And here I'm invoking it, an example of invoking it. And in this invocation, okay, I'm passing in the array 1, 2, 3, which is an array of numbers. And here's my particular mutator function that I'm passing in. I'm using the arrow syntax, and I'm using the shorthand form of the arrow syntax. And it looks like my mutator just multiplies each number by 10 and returns the results. So the result should be based on the input array. The result should be 10, 20, 30. And if I run it, I can tell you that based on the various console logs that are in this file, this is the console log produced by that particular invocation. Yeah, so the important point anyway from a TypeScript point of view is just here. This is how I specify the type of the callback that's being passed into this particular function. I've got another use case of the mutator here. What am I doing here? Let's see. Okay, so this is actually going to be my mutator. I've just decided to, whereas I'm using an anonymous function up here, this is an anonymous function you remember from last year. In the second case here, I'm actually assigning my mutator to a variable. And then I call my array mutator here, and I'm passing it in my mutator function. And my mutator function, again, is consistent with the type in the sense that my mutator has to be a function that takes a single parameter of type number and returns a number. And this function indeed honors that signature. Now, that's fine. This syntax here, this syntax that we use here, it's okay, but it can be difficult to read. And if you had a number of functions that took a mutator function as one of its parameters, then repeatedly typing this can be a bit long-winded. Now, this is where type aliases can be of assistance to us. And I'm showing you an example down here where I'm saying, here, if you take this line here, right? I'm using the type alias aspect of TypeScript now, and I'm declaring a type alias for my function signature. Now, this is something you cannot do with interface data types. So this is one example of where type aliases become a little bit more powerful than interface data types. So I'm declaring this, what did I call it? Mutator function type. It's a custom type I've defined for myself, and it's equal to this signature. And how can I use this custom type? Well, I've just decided to define a second function for myself called array mutator2. And it also takes two parameters, an array of numbers. And here's where I'm using my new custom type that I've just defined a couple of lines up. So it's just that it reads a little bit easier, provided you give this new type a meaningful name. It can read a little bit easier, because if you could imagine where a callback takes a number of arguments, then that's going to span right across this line here, and it can be difficult for people when they're reading your code. So that's just in passing. We can use type aliases to declare function signatures, essentially. And I'm just calling my function here again. You can look at the detail yourselves later on. Let's see. So that's higher order functions. Yeah, all I'm getting at down here in this part down here is just moving away a little bit from higher order functions. And I'm making the point. So I've got a function here called fetch data, and it takes a single argument of type string, and the string is probably meant to be, it looks like it's meant to be a URL. And the function returns a promise. Now, the question that I'm kind of putting to you is, what's the signature of this function? So if I do Command K, Command I, because I'm not being specific about the signature of the function, I'm letting type inferencing do its thing, I suppose. Or, sorry, to be more specific, what is the return type of this function? I'm not being specific about it. In fact, I wasn't, whereas up here, back up here, let's say, I was specific about the return type, but I could have actually left that out. I think I could have left that out, and type inferencing would have done its thing. But going back to this example here, I'm letting type inferencing do its thing here as well. And the question is, what is the return type? Well, if I do Command K, Command I, it's saying that the return type there is of promise string. It's a promise of a string. And that looks like it's correct because just based on, I mean, it's hard coded, but I'm returning a promise of a string here. So TypeScript understands the promises model within JavaScript stroke TypeScript. Another example here is where I've got a similar kind of function, and in this case, the function is also returning a promise, but it's a promise. It looks like it's returning a promise of a custom type of mine, a person. Person is a type that I've defined. I think I've imported at the top of the file. You can see person there, and I've just defined it in my declaration file. If I go into it, where have I declared it? Okay, there's the person type. Nothing too interesting, but go back to functions. Right now. What I'm wondering is, will the compiler infer that the return type properly for me here? Because it looks like it's returning a promise of a person. And if I do Command K, Command I, it actually works that out as well. You can see there on the right, it's worked out that it's returning a promise of type person. So it looks like TypeScript understands the whole promise model as well. And promises are going to be an important part of the distributed systems stuff that we will be eventually get to work on. But for now, anyway, it's higher order functions, and I'm showing you how you declare the signature of the callback. That's how you declare the type, if you like, of the callback. And we've had a couple of examples of it there. The next aspect of the language is something called optionals. This is a very straightforward thing to grasp, I think. Optionals are where you want particular properties in an object structure to be optional. Sometimes they may exist, sometimes they may not exist. So if we look at an example here, I'm declaring a user type for myself, and I'm saying user has an ID property of type string, a name property of type string. And here's where the optional part comes in. I'm saying they have an email property, but the question mark here is indicating that some users may not have an email property, and we're accepting that as being okay. If they do have an email, then its type has to be string as well. I'm saying some users may have a social property. Question mark here is indicates that it's optional. If a user object has a social property, then the breakdown of that social property, it has to have a Facebook property, and it may have a Twitter property, and or it may have an Instagram property. So it's this question mark is indicating where the optional properties are within my overall type, my user type. Now I'm using it here in the context of interface data types, but you can use this optional syntax with type aliases as well. And finally, I should say that every user has to have a status property. So these optional properties can be anywhere within your structure. And we've got some examples. We go into a new file called this one here. See, where is it? Yeah, here. And it looks like it's the example from the slides. So here's my interface data type. And then I've just got some examples of users that are variables that are declarative type user. And it looks like the Joe variable does not have an email. He does have a social property, and the social property has a Facebook within it, which is mandatory. Doesn't have Twitter or Instagram. If I change this, let's say I change this to Twitter. You can see now that the compiler is complaining. And if I bring up my promises tab, essentially what the compiler is complaining about is I have said that the social property must have a Facebook aspect to it, and this one doesn't. So it's that's why it's complaining. And I'll undo that to correct this. Another example of a user, this user has an email and doesn't have a social property. It's still a valid user though, because it respects the user type that I declared earlier on. Third example doesn't have does have an email and also has a social property. So they're all examples of valid users. Now we can use this optional indicator also with function parameters. You may have functions where some of the parameters you consider them to be optional. The function can be invoked without actual values for those parameters to be passed in. Of course, you have to take care of both scenarios in your function implementation. Scenario where the function is invoked with a value for the optional parameter, and the case when the function is invoked with no value for that function parameter. In other words, it's undefined. That's the point I'm making at the very bottom of that slide. To go back to the code. So we've got this function here and print ingredients. It takes a string, which is a mandatory parameter, a quantity, which is a mandatory parameter, and it looks like the third parameter is an optional one. Again, using the question mark symbol to indicate that. And okay, my function doesn't do anything interesting other than does a console log out to the screen. And here are examples of invoking the function. So in this invocation, I'm passing it. I am passing it only 2 parameters. In this example, I'm passing it all 3 parameters. Now, there isn't, because the function is doing so little, and for the first invocation, let's say this invocation here, where I'm not passing it anything for the third parameter, just means that this part of my console log is going to be blank, right? So it doesn't cause any problems. But if there was a lot of processing going on inside this function, and it was using extension in some way, then we would have to obviously first of all check, is extension equal to undefined? And if it is, do one thing. If it's not, do something else. So you have to build that into the logic of the implementation. I didn't have to in this case, though. The point I'm making by virtue of the code that I've commented out here is that optional parameters cannot precede mandatory ones. Ingredients and quantity are what we would call mandatory parameters for this function here. Now, like I couldn't, for example, switch the position of extra info and quantity. I can't switch if I even try to do that, let's say, if I just copy this or cut it out completely. And then bring it in here. Then we get an error. Are we getting an error? Oh, yeah, we're getting an error here. And if we want to see the detail, it will essentially tell us, if you read the detail, that you can't have a required parameter after an optional one in a function declaration. So that's the only constraint. And do all of that. And that's the point that's being made here, really. So I don't need to go into it. Some more on type aliases. Oh, yeah. So if I go back to the structure here, it's not very long, but uh, you could imagine where you have a type structure that has a lot of properties, and especially if it has a lot of nested structures within it, this being a nested structure, then could we actually write that in a slightly clearer way or a more user-friendly, developer-friendly way? And that's what I'm doing down here, and I'm illustrating some points as well. So type aliases can be of use to us. Where do I start it? Okay, here. Okay. So I'm defining using type aliases. I could have used interface data types for this one anyway, but I decided to use type aliases. So I've defined a type alias for called social handles that looks like that. I've defined an address. I'm broadening my user type now a little bit, admittedly, but I'm defining an address type that looks like this. I'm defining a contact type, which I'm saying could be social handle or address. We can't express that kind of stuff with interface data types. So I could only use type aliases for this line here, but I could have used interface data types, as in I could just go interface. And remember, you need the take out the equal sign. So you can mix and match those. And to get back to here, my contact type is of type social, handle, or address. And I've defined a new user type because I didn't want the name to clash with top of the file. So I've got a user v2, and a user v2 now has this property here called contact, and it's of type contact. And so instances of user v2, Kyle is an instance of user v2, and it looks like Kyle's contact property, which is mandatory. It looks like it matches the social handle structure. In fact, if I do Command K, Command I, and that, I wonder what will it tell me. Okay, it just says it's of type contact, so it's which is true. Whereas the Jenny variable has a contact which looks like it's of type address, really. Okay, and that's the end of that example. So it's just another example of using type aliases to make your code a little bit easier to read. And the easier to read, I would argue, is, here, my user type isn't as long as it was at the top of the file. Admittedly, though, it's a small example. And there may be other data structures that use the address type in it and or the social handles type in it. So there's a reusability potential going on there as well. Moving on, what am I trying to illustrate here? Okay, there's just a function that's using a function. Is that what it's doing? Okay, this function, you pass it a parameter of type user v2, and it returns the, oh yeah, I can remember now what point I wanted to make here. So so we've got this function called get contact, and you pass it in a parameter of type user v2, and it essentially extracts the contact details of that user and returns them. And so here, and we know now that the contact can be of type address or social handle. So I do need to have some sort of conditional test in my code to determine, well, what type of contact is it? And that's what I'm doing in this line here. And I've arbitrarily decided, well, if the contact contains a property called street, then I know it's an address contact. And I return this string here. The point that I want to get to do is if I do command K, command I on this variable, it actually works out, the compiler works out that it's of type address. Whereas in the else part, do I have an else part? Well, the else part is kind of defaulting to here. So if I do command K, command I on this variable, it can only be of type social handle based on the flow of control in that function. And again, the compiler has worked that out. The technical term for what I'm doing here is called type narrowing. I have a type that's coming in called contact. It could be of multiple types, and I'm narrowing down by virtue of my if statement, I'm narrowing down the specific type that contact is. In this case, I've narrowed it down to be either of type address or of type social handle. I wouldn't worry too much about it, but I'm just illustrating that point again, that this type narrowing is something that the compiler can essentially follow the flow of control in your code, and it can perform type narrowing behind the scenes. And so inside here, like, because now the compiler knows that this variable here, probably should have called it something else. I probably should have called it address because I know that would be a more meaningful name. But the compiler knows now that the type of this variable that I've highlighted is address. So if I wanted to do something, right now, if I go contact dot, you can see that the compiler is saying to me, well, the only two properties that you can reference are street and name. It did not give me the social handle properties in here, sensibly. Okay, so just another example of the power of the compiler. Back to my slides. That's optionals, union types and type literals. So a union type, I'm saying union types, we use them when a value can be more than a single type. We've actually seen this before, but I'm kind of covering it formally here. And if you look at the example, so I've defined using type aliases, and I can only use type alias syntax. I'm defining a type called size, and I'm saying it could be of type string or number. And here I'm declaring a variable called class size. It's of type size, and I'm assigning it a string. And that's consistent with my size type. Whereas here, I've got another variable called bottle size. It's of type size, but I'm assigning it a number. So the point, so well, I would say that size here is it's a union type. It can have different types of values associated with it. In this particular case, they are string and number. Second example, of defining a role type for myself. And let's assume that I've defined a student type and a lecturer type and a manager type somewhere else in my code base. So we can use, we're not just restricted to primitives here. We can use custom types as well. So role is another example of a what's called a union type in TypeScript. So that was a bit like our contact in the previous example. Literal types. Literal types are where you're declaring a type and you're being very specific about the set of values that instances of that type can have. So I think the example might be, make it a little bit clearer. So I'm declaring a type here, not declaring a variable. I'm declaring a type called degree nomination. And I'm saying that wherever you declare a variable of this type, that variable, it can only have one of these four values. So it's a bit like an enumerator from other languages. Okay, so that's literal types. Don't know if I've got examples of it. So I think the examples on the slides hopefully are clear enough. I do have an example. So I've got a department, declaring a department type here. And this is an example of a literal type. And I'm saying department, the only possible values are engineering, sales and accounts. And then I've got a function here. It takes a department parameter. Okay, the function isn't a very sensible one, but and it's doing some sort of check to see, well, maybe the point I'll make here is as you're typing the code, so if I just if I get rid of the, let's supposing I'm writing this function kind of live. So I've got if department equal to, so here's the point that I want to make. Again, the compiler is telling me that the only values that I can put at the right-hand side of this equal statement are the strings accounting, engineering, accounts, engineering, and science. So the compiler has worked its way back to the declaration of the department literal type, and that's what allows the compiler to come up with these suggestions for me. If I try and type any other string here, I'm obviously going to get a compiler error. So the point I'm trying to make is that the compiler helps you as you're writing your code. It helps you, or it sort of prevents you from making mistakes. If this was JavaScript code that I was writing, then I could put any string here and I won't know until I run my code that there's a potential bug in my code. Can't remember which one I had. Let's say it was engineering. You see how it complained? It can't be engineering here and engineering down here. So let's correct this. Let's say accounts. Okay. So that's literal types, an example of literal types. That's all I've got in that file. What's next? Next is something called generics. A very powerful part of the language, but by no means unique to TypeScript. You may have come across generics already in other languages. The first place I came across generics was in the Java language. And I'm going back a number of years now when generics was introduced to Java. I'm not sure, I should have checked really whether Java was the first language to introduce this concept of generics, but certainly other languages have adopted it. And the purpose of generics is to try and help you as a developer to develop reusable, what I'm calling reusable components here in the slide, where component is a very kind of general, non-specific word. But what it would mean, for example, is to try and write functions that are reusable, classes that are reusable. That's what we could mean by components in the context of TypeScript. So I'm making the general point that a major part of software engineering is building components that not only have well-defined interfaces or APIs, but are also reusable. We're always striving for that in software engineering. Now, what generics allow us to do is essentially generics allow us to postpone being specific about the data types that are being processed by a component. So if we just talk about a function, for example, with a generic function, with a non-generic function, you have to be specific about the data types of the parameters, for example. With a generics function, you don't have to be specific about the data types of some or all of the parameters. You actually delay specifying the types of the parameters until you want to invoke the function. Similarly with classes. So we have this notion of a type variable, which sounds contradictory because up now I've made a distinction between a type and a variable, but we have this concept of a type variable in generics. And it allows us to create classes or functions or even type aliases that don't need to be explicit or to explicitly define the data types that they use. Sounds like a bit of a tongue twister and a kind of circular argument, but it is a very powerful feature, and we see it quite a lot actually. So in this very simple example here, I've got a function, and I've given it a pretty meaningless name called process. And this part here, this angle brackets t here is what we would refer to as a type variable. Can be anything, right? I can use anything. I can use t seems to be a convention, but you can use u or k or anything you want to really. It's a variable, and just like any variable, you can call a variable anything you want to. When it comes to type variables, we tend to, by convention anyway, use a single capital letter, but you don't have to. So t is here as a type variable. And the first thing I would say now is that this process function is an example of a generic or a function that has generics built into it. The function takes parameter like any function does. First parameter I've decided to call element, and I'm actually using t here again. So I'm saying that the type of this parameter, I'm not being specific about it. I'm saying it's of type t, which matches this t here. But it's still just a name, right? It doesn't have a meaning yet. It takes a second parameter, and in this particular example, the second parameter does have a specific type, as it turns out. And it doesn't really matter what the function does. It does some processing of elements. So here I'm declaring the function. Here is where I'm invoking the function. And when you invoke the function, that's where you specify exactly what type is the type variable. And so let's supposing I have declared a type called person somewhere else in my code. And I'm saying that the type for this particular invocation, I want the variable t to assume the type person, which is a real type, whereas t is not a real type. That means that the first parameter, element, it has to be an object of type person. And let's assume that person x is a variable that I've declared somewhere, and person x is of type person, and I've assigned a valid value to that person x variable. Here's another example of where I'm invoking the same function, but in this case, I want the T variable to be assigned the box type, which again, let's assume I've declared that somewhere else in my code. That means that the first parameter has to be a parameter of type box. And based on the name, let's assume that the box y variable is a parameter of type box and a number as well. So two things. This is how we declare a component, in this case a function, declare it and state that we are using generics in the declaration of it. And this is how we invoke the function and we specify the exact type for our generic type variable. Can be a little bit off-putting initially. Now, I've got some examples. So we're moving into the generics part. There's a bit going on here, but let's try and break it down for ourselves. Am I looking at the right one? Yeah, okay. So just by way of background first, I've got an array of, looks like it's an array of strings here. I haven't specified it, but yet again, if I do Command K, Command I, it's an array of strings, that's fine. And I'm invoking the sort method on my array. Now, sort is a method that comes from JavaScript, okay? As most, a lot of stuff for TypeScript comes from JavaScript. And the sort method is a method that we can invoke on an array, and it does what you think it does. It sorts the entries in the source array, and it actually changes the source array. So it's unlike map and filter, which don't change their source array. Sort does. And the sort method, this has got nothing to do with generics now so far. The sort method takes a callback, and the callback essentially expresses how the sort method should sort the elements in the array. You have to tell it how to sort them. And it looks like in this particular case, and the callback, it has to have that particular signature. It has to take two parameters and it has to return a numeric value. Well, I'm not giving you specifying the signature here, but I'm telling you, if you looked up the sort method yourselves, you'd see that the callback has to take two parameters. You can call them anything you want to. I've called them A and B. These parameters A and B have to have the same type as the entries in my array. So in my example, A and B would be of type string. And the callback has to return a numeric value. And the way the sort works, and you can read up on it yourself, or you may already be familiar with it, the numeric value that's returned, if it's negative, it means that B is bigger than A and therefore should appear after A in the sorted array. If the return value from this callback is 0, then A and B are of the same magnitude, so it doesn't matter which order they are in the resulting array. And if the result of the callback is a positive value, it means A is actually bigger than B and should appear after it in the sorted array. Okay, so that's how sort works. Okay, that just comes from JavaScript. So it looks like in this case, essentially, I want to sort my array based on the length of the various strings in the array. And if I run it, I suppose, and I'm console logging it, and if I run it, I get the result that you would expect me to get, but just to prove it, yeah, so I'm getting the strings in increasing length order. So that's fine. That's just sort, and that's by way of background to what I really want to talk about, which is generics. But before I talk about generics, let's suppose we did not have generics available to us. And that's what I want to get across in this code here. So I've got a function called, looks like I've got a function I've declared called string ranker. And the idea of this function is I want to pass it an array of strings, which I am doing here. And I also want to pass it a function which will help my string ranker function to rank the functions in increasing order. So this ranker function, and we can tell that it's a function based on the type that ranker is. The ranker function, I can use it within the body of my string ranker to sort the array essentially. And you can see here, I'm using sort and I'm using my ranker callback function that I've passed in. Yeah. And then I'm returning the result. And here I'm invoking my string ranker custom function. I am passing it in an array of strings. And here's the particular ranker function that I'm using. And again, I've decided to use length as the basis for which my string ranker function should do the ordering. And I console log it. And surprise, surprise, I get the same result as you can see down here on this line here in the output. Okay. But I could call my string ranker function with a different criteria for ordering. I've just decided to use length. I could use a function, let's say, that counts the number of vowels in a word and use that as the basis for ordering them. Okay, I've got another custom function here called person ranker, which kind of does the same thing as string ranker, except this person ranker function, it works on an array of person objects. And you can see the first parameter I'm passing it into is an array of person objects. And person is, again, we know is an interface data, or it's a type that we've defined for ourselves. And I'm passing it in a ranker function. And the signature of this ranker function looks like this. Okay, takes a person and returns a number. It always has to return a number because that's the basis on which the sort works, as I tried to explain at the very beginning. So that's fine. And here is the body of my person ranker function, and it's using sort again to sort my array of person objects and returns the result. And to illustrate then, I've decided to create some person objects. I've got 3 person objects, is it? 3 person objects, and then I invoke my person ranker. Well, sorry, I declare, this is my ranker function that I've declared for myself. And based on the name, it looks like it's ranking people by age. And then I call my person ranker function here. Let's see, where am I calling it? Oh, sorry. Let's see, what am I doing here now? I'm essentially declaring a function which is invoking the person ranker, passing in an array of person objects. That's fine. And this is the ranker function that I'm using. And it looks like I'm ranking persons on the basis of their age. I'll come back to why I've got this question mark, this ternary operator stuff going on here in a second. But I'm ranking persons on the basis of age. And then I just invoke my person by age function. And I'm console logging. And if I look down here, it looks like it's ranking my 3 person objects by age, increasing order of age. Is it doing it right? 21, yeah, 21, 22, and 30. So it's working for me. Just to go back and The only slightly odd thing is this here. Why did I do that? The reason I had to do that, probably didn't think it through, but if I look at person, the structure of person, I said that age is optional. It was just an example of the optional uh, characteristic that I've talked about already. So that must mean if age is optional, then it's possible that I will have a person that doesn't have an age property. And so how does sort work then if it gets an age property that's undefined? It can't, obviously. Now I could make life a lot easier for myself and just change that to make it mandatory. But let's supposing I wanted to have age, leave age as being optional. How do I accommodate that in my example? As I said, now it's kind of an unnecessary complication that's not focused on what I really want to get at, which is talking about generics. So it is optional, and I have to work with that. And see, if I just take out all this code here, if I just forget that it's potentially undefined, I actually am getting an error. I'm getting an error from the compiler. And if you looked at the error, it's essentially telling you that it's possible that age could be undefined. And that would mean that my ranker function is potentially returning undefined, but it can't. It has to return a numeric value. That was the that was the requirement. So I have to deal with that situation. It has to return numeric. So I just arbitrarily decided, well, look, if if I get a person object that doesn't have an age, then default the age to 30. Okay. So that's an example really in TypeScript where, it just won't let you get away with ignoring the fact that it's, in this case, ignoring the fact that sometimes a person object may not have an age property. It's catching it at compile time and it's forcing you to deal with it. And that's the way I've just arbitrarily decided to deal with it. Now, back to generics though. It looks like I've got two functions here. I've got person ranker and I've got string ranker that are essentially doing the exact same thing. They're doing the same processing, but with different types. Is there any way I can combine those two functions together into one? And that's where generics comes in. So here's my solution with generics. I'm just defining a function which I've decided to just call sorter, and it's a generic function. So it takes a type variable, which I've just arbitrarily decided to call it t. The first parameter is an array of t's. So it could be an array of persons, an array of strings, an array of boxes. The ranker function is a function that has to take a parameter of type t and return a number. It always has to return a number because that's the way the sort method works. And the body of my generics function, I mean, if you look at the code, those two lines of code, it's the exact same as the two lines of code that I had here, and similarly in the string ranker function. So, okay, here's my function declaration. Now, how do I actually invoke it? And here I'm invoking it in the case of sorting an array of persons, and I'm saying I want T to be assigned the type person. And that must mean that the array that I'm passing in, it also has to be an array of persons, because based on my function declaration up here, whatever T is here, then it has to be an array of T's that I pass in as the first parameter. And so that's consistent. And again, I'm using my age as a way of determining how to order the person objects. I didn't, do I invoke it with the strings? Uh, oh, I do, yeah. I invoke it with the strings here. Okay, so I'm passing in an array of strings and all the rest. The point I'm trying to highlighting here, though, is, and it's by virtue of the comment, how come I didn't put in here angle brackets string? Sorry, now. And the answer is, well, I could have, and it's all still going to work fine. Look, I don't have any errors down here. And the answer is, well, I've actually let generics take care of that. How did it work? How would it work out that it's T is of type string? Well, if this, it looks at this array here, and it notices this is an array of strings, and based on my definition of the sorter function, whatever this array type is, well, that's what T gets its type from. So it's an array of strings, so it knows T is equal to the string type. So I let generics essentially take care of that for me. So I can take it out, and could I have taken it out up here? Looks like I could. It's not complaining. So, but as a beginner, you wouldn't necessarily identify that possibility for yourself. So that's generics. That's one illustration of generics. Admittedly, if you've never come across it before, it can be quite a tricky thing to wrap your head around. I do not expect ye to be writing code, designing code that involves using generics. I'm not expecting that, but I do expect you to be able to read code that's using generics. Obviously, after 2 weeks looking at TypeScript, you're not going to be expert TypeScript programmers, and generics is quite a complex concept anyway. So you just need to be able to read TypeScript code that is using generics. It makes sense of it. Generics, though, it's not just restricted to being used in functions. We can use it in classes. I don't have an example of that, but you can use it in data types as well. And I've just added in an example of that, I think. Where do I have it? Oh, yeah. If we look at this example here, so I've got a microphone data type, and I'm using the interface for no particular reason. I've got a speaker data type structure, and then I've got a box, and my box I'm using generics for. So what I'm kind of thinking of is that I could have boxes of different types. A box has a shelf number, and it has an array of things where all the things are of the same type. So by using generics here now, I will be able to have variables that represent a box of microphones or a box of speakers or a box of whatever. So I can use generics in data types just as well as in functions. And you can see the example down here. I've decided to create a box of speakers for myself. And the final comment is we can also use them on classes. Well, I'm using them up here on type on data interfaces, but I could have changed these data interfaces to type aliases, and the generics would work as well. In fact, you can use generics right across the board. But I think we'll probably only see it being used in the context of classes and functions. Okay, now I know I'm going through this at a very fast pace, and uh, obviously means you're going to have to review this lecture. And the purpose of the lab is to give you an opportunity to see if you can actually apply it to a very small, constrained examples. Back to my slides, which is the last in the set of slides, and it's about utility types. And so TypeScript provides a whole set of utility types. And what they are about is they allow you to, I'm saying here, to transform. They're about transforming one custom type into another type, performing type transformations, which is something that we do quite a lot actually. So they're built into the language, and if you look up this URL, you'll get a list of all the utility types that are available to us. And I'm just going to illustrate a small number of them. There are other utility types that have been provided by the community, but the essential point is that these utility types allow you to create new types based on a transformation of an existing custom type. So I suppose if we just look at one or two examples that was included in the archive. Now, as I said, there are quite a number of these utility types, so I've just picked a small number of them. So I've got a custom type here called tech user, and it has some properties which are fine. Then here I want to create a new type called tech user optional. So the idea in my head is that I want to have a type which has the exact same structure as tech user, but I want all of the properties to be optional. Now, I could do a cut and paste and uh, do some editing. Uh, that's fine. I could do it that way by longhand, but I can actually use a utility type to do it for me. And in this case, the utility type is called the partial utility type. So with the partial utility type and all of these utility types, most of them, or a lot of them, actually use the generic syntax, just by the way. So this is how you kind of use the partial utility type. You give it the name of the custom type that you want the partial utility to work on, if you like. In my case, is tech user. And if I do a command K, command I on the result, which is here, if I do command K, command I, you can see it has the exact same structure as tech user, but all of the properties are optional. And that's what I wanted to achieve. And so the kind of advantage in this of these utility types is if later on during the evolution of my application, I add some more properties to tech user, then automatically this data type is going to have those additional properties and they will be optional as well. Whereas if I use the cut and paste approach, then I would have to remember to update the tech user optional implementation that I did. So that's partial. It makes all the properties in your source type, if you like, optional. Here's another example. Well, I'm just using it there, but you can look at that yourselves. Here's another example. There's the required utility type, which is kind of the opposite of partial. What required does is it takes the source type and it makes all the properties of the source type mandatory, and it declares a new type following that result. So again, if I do command K, command I on this, you'll see that email now is mandatory, whereas in my tech user, email was optional. Another example. here, sometimes you want to declare a new type which takes a subset of an existing type's set of properties. And so the pick utility will do that for us. And the way we invoke it is we specify the source type, and then we list the properties of that source type that we want to have picked out of the source type and put into my new type. It's unfortunate that I'm using the or operator here because that would suggest it's this or this, but it's really this and this. So again, if I do Command K, Command I on, what did I call it? Just email and name. Okay, not a great name for type, but anyway, Command K, Command I. It just has the name and email property from tech user, and it has preserved the optional characteristic of email from tech user. Again, you remember tech user from the top here. Email was optional. So let's pick just another example of utility type. Let's see. Sometimes uh, it's easier for you to state the properties that you want to have omitted from the source type. And that's what the omit utility. So whereas with pick, you specify the properties that you want to have included in your new type. With omit, you specify the properties that you want to have omitted from the source type and put into the new type. So in this case, it looks like I just want all the properties of tech user except ID and email. And I want that to be put into my new type. So if I do Command K, Command I on that, you might predict that this is what it would include. You can nest these utility types. What I mean by that is, supposing I wanted all of these, all the properties in this new type to be optional, then and that means, can I use the partial utility type? Well, I can, and this is how I would do it. Just nest your invocations and make sure you close off everything appropriately. And now if I do Command K, Command I on this, the properties are optional. Here's my objective. So that's just 4 of the utility types. The last one I'm looking at is record. What a record does is it essentially kind of allows us to create a kind of an open-ended object structure. So in this case, I'm using the record type to create a map for myself. And I want the keys of the map to be, let's say, tech user's ID and the value to be a tech user object. If I maybe show you what I'm trying to get at when I run it. So I've got this, let's see now, I've got these users. I just got 2 users, let's say, and I want to create essentially kind of a lookup map of my users. And what the lookup map will look like is, I just run this example. This is what I want to produce. This is what I'm calling a lookup map, which is something that can be quite useful in programming. So the lookup map in this case is a lookup map for all of my users. The keys are the IDs of the user, and the values are the actual user objects themselves. Now, how do I define the structure of this map? You see, because the values, well, okay, so that's what I want to achieve. And how do I kind of put a type on this structure here? And it's quite convoluted, I suppose. I'm just wondering, should I get into the detail of it because it's quite a complex example. Let's just see. So I'm saying I've got this type called tech user map by ID, and it's a structure using generics. It's a structure where the keys are of this type. Um, what I'm doing here is I'm referring to a particular property of another type. uh, so I've got this tech user type, and I'm referring to the ID property. And you remember the ID property is of type string. So this is essentially saying that the keys in my map will be of type string, and the values will be of type uh, tech user uh, programming. Where's tech user programming declared? Okay, so that's tech user programming. Okay, and then what I'm doing here is I've got a function that actually produces my map for me. And this function takes a tech user array, and it looks like it maps over them. Or it's using the reducer actually. It's probably a little bit overly complicated now. And the function is returning it's returning a structure of type tech user map by ID, which is this one here. And I'm passing in an array of tech users, and I'm using the reduce method to iterate over my array of users. And you might remember the reducer from last year. I give it an initial value for my overall result, which is an empty data structure, an empty object, if you like. And I'm iterating over it. It's quite complicated, I think, really. Not sure if I really want to get stuck into explaining it line by line. Probably over involved. Right. That's as much as I want to cover in TypeScript. And I think what my overall objective with Ye is that obviously you need to be able to write TypeScript code, but it's not going to be uh, um, challenging from a TypeScript point of view. It will be JavaScript as much as TypeScript that you'll be writing. I do want you to be able to read TypeScript code. So when I provide some code related to distributed systems, it'll be written in TypeScript. It'll have examples of generics, not a lot, but it'll have some examples of generics. It'll obviously have interface data types and type aliases and all this stuff going on, type annotations. So you should be able to read that code and make sense of it and write equivalent code from that rather than designing something from the ground up purely in TypeScript, which would be probably overambitious, really, given that we've only taken 2 weeks to look at the language. Right. Now I'm actually a little bit ahead of time as it turns out. So unlike me, I'm actually going to finish the lecture on this. If I look at the lab, I suppose at this stage. So if we look at the different sections in my lab, you can see now that we've covered all of them, right? We've covered interface data types, so you should be able to um, complete that section. There's an exercise at the end of most of these sections, which will help you to um, work out whether you actually understand the syntax of the language or not. But moving on, I've got a section on functions, which we've looked at, section on optionals, which we've talked about, on type aliases, which we've talked about, on generics, which we've talked about, and on utility types. So I've tried to cover all of the different parts of the language that we've looked at. Now, there are many parts to the language that I have not looked at, and I've just chosen the parts that I need for the rest of this module. So in no way, as I've kind of mentioned before, in no way could we consider ourselves to be competent TypeScript programmers. I don't expect that from you at the end of this module, but certainly you can read TypeScript code. So uh, you can now work your way through this lab. And I haven't logged into Moodle here, but what you will be submitting, and you will be submitting the lab to me for assessment. What you're submitting though is, as you probably know, just the URL of the GitHub repo that you'll be pushing your code to. And so you can submit that straight away, but you can still continue on working on the labs. And I will give you all of this week to work in the lab. And in fact, you can take next week to work on the lab as well. Next week, I will start into distributed systems properly, in the sense that I want to cover some aspects of start looking at the AWS platform and looking at, well, the first topic I'm going to look at is infrastructure as code. So we will be writing TypeScript code, which will be describing infrastructure that we want to create up on the AWS platform. So that's where I really want to take the language into that particular application area. But so you have all of this week to work on this lab, and I'm going to give you all of next week to work on the lab. So I'm going to set, let's say, Friday of not the coming Friday, but the following Friday as being the completion date for this lab, which means I don't want you doing any commits to the GitHub repo after that date. Right. Are there any questions that you have for me? So there's a lot to take in there now in terms of what I've done today and to be able to work through that lab. So you are going to find the lab, I think, quite challenging, but that's okay. Right, I'm going to leave it at that for now. Thanks for tuning in. Bye-bye.